certainly have very interesting audience. I'm looking forward to discussion. So welcome everyone to this session of Augmented Intelligence Workshop. Augmented gaining new meaning as we go along. So as you know, in this series of short talks, we are discussing various ways in which our individual intelligence can be augmented or not in social and other technological ways. It is organized by Rob Goldstone, Marina Dubova, Gautam Biswas, and myself. And I'm super excited about today's speakers, which I know and love for a long time. David Garcia is a professor who is too young to use words like long time. David Garcia is a professor for social and behavioral data science at University of Constance and still has appointments at Technische Universität Graz, Complexity Science Hub Vienna, and ETH Zurich. And he will be talking about collective emotions and how we can use digital traces to study and understand them better. And Rick Dale is a professor at the Department of Communication at UCLA, and he will be talking about large language models which are kind of an intersection of pre-trained AI systems and us researchers. And maybe he will also show us how they can help us understand what we have been talking about here in the course of this workshop. And David and Rick, I would say, both work on methods that help us understand the augmented side of our intelligence, like, for example, Steph Frey, Michael Richardson, Mark Sears, Charles Wu, Sudeep Bhatia, Phil Metzner. They develop these methods that help us to probe various sorts of augmentation from social to artificial. And then, and in a way they help us to talk to these augmented parts of our intelligence in a way we would talk to individual human participants. And that then helps us to develop theories of when augmentation contributes to individual and collective intelligence, when not, and so on, and study all these intricacies in this interplay. So before David takes it away, followed by Rick, let me just note that meeting is being recorded. It will be posted on the YouTube channel. And so make sure your microphone is turned off when you're not speaking. Feel free to post any meeting related thoughts and questions in the chat window. We will post it later on Slack. And then after each talk, we will take a couple of questions specific to the talk. Just raise your hand or put your question in the chat. I will moderate. And then in the last 20 minutes or so, we'll open for more general discussion about the relationships between the talks and augmented intelligence, more general. So thank you very much, David and Rick, for being with us and everyone who is here. And David, please take it away.
Thank you very much, Mirta, and thanks everyone for the invitation and for your time today. It's a pleasure to have such a nice audience of experts in these topics. It's really cool to talk to very different people with different backgrounds today. So I put a link to my slides in the chat in case you want to see them later or check anything while I'm talking, but I will share my screen. Good. So I guess that you can see my slides now, right? Yeah, very good. All right. So yes, I'm going to present my work on studying collective emotions, in particular how we do that with social media data and applying NLP or a fancy version AI to study emotional expression. And first, a bit of an introduction. This is a work in collaboration with my team. I recently moved to the University of Constance, where I'm starting a lab in social data science. But most of my team is actually distributed between Vienna, Graz, and now I'm hiring here in Constance. So I'm really affiliated to institutions in all three cities, and we're collaborating. We're a Zoom research group. We just meet several times a week over Zoom. And the work I'm presenting today is interdisciplinary collaboration with people in my team. For example, Hannah Metzler is a psychologist. Jana Lasser is a physicist turned data scientist. Segun and Petar are computer scientists. And also the undergrads, Anna is mathematician, Alina, a psychologist, Apexa is a communication scientist, and Emma is a physicist. So we really mix backgrounds and try to learn from each other as much as we can, because none of us has all the keys to all of the research we do. We'll have to put our hands together to do things in a sustainable way, so to speak. So the research I'm presenting is funded by the Vienna Science and Technology Fund that funds most of my lab in Vienna, and also by the European Research Council in a project in collaboration with Steve Lewandowski, who is also today with us. That has also helped us to put some effort in developing some of the methods that I will talk about today. So the topics that we study, of course, so computational social science / data science is very broad. And we try to focus in particular on understanding human emotions with digital traces and computational methods, what we call computational affective science. We also study polarization dynamics, in particular using agent-based models and digital traces to study how people assort themselves into groups or have different patterns of cognitive balance when interact with each other. We also study information disorder as a general topic, for example, misinformation, but also conspiracy theories, hoaxes, and other kinds of problems related to this kind of new society that we have in which we can't really trust everything going towards the truth. And finally, we also study privacy, in particular, how network decisions and network effects affect the individual power to keep your data private, what I call complex privacy. And that will be a nice topic to also cover today in this augmented intelligence workshop. But for the sake of time, I will focus mainly on collective emotions, which I think is the main case I can make. But there will have been other things I would have liked to present. Maybe next year, or I don't know if you've organized this another time. I'll be happy to comment on those. All right, so what I want to cover today, first, I want to tell you about collective emotions and why I think this is a topic that will be interesting for this idea of augmented intelligence. Second, about some methods we've been developing to detect individual emotions on social media. And third, how we're applying those to study emotions at large scales and to validate the methods that we've been using already for about a decade to see if they're actually capturing a signal of emotions in society. So regarding collective emotions, and the idea of a collective emotion is an emotional state that is shared by a large amount of people at the same time. So that's this basic definition from the book of von Shiva and Salmela about a decade ago, where a lot of people got together, and one of the first definitions was written there. So basically, we have first, it has to be an emotional state. So it's not an opinion or a belief; it's really a short-lived emotion that is shared. So there's people that are actually in contact with each other and share that emotion. It has to be a large amount of people, so it can't be just an individual or a couple of people. It has to be a crowd. How large is a crowd is an open question, but it has to be more than just a small group of people. And at the same time, so it has a synchronicity. That's why the example of people celebrating a goal of their team or people being angry at a riot are common examples of a collective emotion. So collective emotions are complex behaviors in the sense that they can emerge in a group without a necessary easy event that is causing them. They can also be triggered by an event that everybody sees, like example of the goal, but how they operate might be very different to what happens to an individual person in complete isolation, in the sense that they could, for example, last longer than an emotional reaction for a person alone. They could be stronger or become more intense because you're interacting with other people, or they could change in quality in the sense that you might feel an emotion of one valence when you're alone, but it can have extremely different valence when you are with other people. So a pointer on some literature that we wrote recently, also with Amit Goldenberg, who is with us today. We try to define those necessary conditions for something to be a collective emotion that go beyond just that base definition of a shared emotion by a lot of people, and more what are these complex properties of the collective state of a crowd being an emotional one. So studying collective emotions is pretty challenging, and that's why psychologists might not have focused on it so much in the past. Experimentation is not as simple as studying an individual emotion. Typical affective science research paradigm, you show people a stimulus, see how they react emotionally to that with some physiological signals or self-reports. And this idea of experimenting with someone gets pretty complicated when you have to experiment with a group, when you have to change conditions, when you have to control for structures of interaction, etc. Is not impossible, and there's of course advances in especially group experimentation, but it has been quite a hurdle for research to happen. Also, measurement is pretty complicated when you're having a group of people. Self-reports can disrupt social interaction processes, and if you're asking people all the time how they feel, that can change the collective emotion itself. And also there's some additional ethical concerns when we talk about experimenting with collective emotions, because it could get dangerous in the sense that if we're talking about very extreme emotions, we need to have good models to tell what's going to happen if we experiment with a crowd. So social media offer an alternative or an additional methodology to observe collective emotions. And I stress the word observe because in a sense it's a passive methodology that just gets data and then tries to study the nature of emotions as they happen in vivo in the real world, where real is the social media world. So of course, there's a natural exposure situation. People see the emotions of others rather than us forcing them to see an emotional content. So it does have pros and cons. It's more representative of social media interaction, but perhaps not so much of other types of interaction. It also lets us, for example, observe people over long periods of time or get additional information on the structure of interaction between people or their demographics or their attitudes. So it could be useful for having additional information than what you get, for example, with an experiment or a survey. However, we know that the methods are still young. We're still learning to use social media data for this kind of research. Samples are self-selected, and experimenting is still very hard and only at the hand of a very few people that might actually have some internal validity in this kind of studies. I will explain that a bit more in detail in the second part of the talk, but there is certain things to take into account, that we can do everything with social media. We can do something that we couldn't do before, but it's not a complete replacement of any other possible psychological research methodology. So first, we need some methods to study emotions with these kind of digital traces. And when we study what people say online, we might have easily millions and millions of expressions in our data sets, and it's not feasible to have human coders telling us the meaning that they see on each and every of the texts that we have. So for that, we have to develop methods that can scale and be applied to large data sets. And there's been a lot of work, of course, on NLP, detecting sentiment and emotions. And myself, I've never really been a developer of these methods. I've been a user. I mean, I'm a computer scientist, so I can, of course, test them myself and improve them myself. But I never really contributed to that line of research until recently, that we thought that we had something to contribute for the first time. In particular, there was something that was always making me uncomfortable about sentiment analysis, especially when it's based on supervised classification of texts that have annotations by people, and then we train a model to predict those annotations and generalize over other texts. And is that most of the time the ground truth, the data we train against, has emotion annotations that are not provided by the author of the text, but they are provided by another person, for example, a crowd worker in Mechanical Turk, that sees that text and then makes an annotation based on that. So for some cases of studying some types of emotional expression, this is quite okay. For example, when we're really talking about the sentimental meaning of something, in a sense that is a normative meaning of a piece of text, what it means for most of people, that's all right. But when we're talking about trying to infer the emotions of an individual that writes that text, there can still be quite a disagreement between what an annotator writes on the text and what the person was actually trying to express when they wrote the text. And this is a measurement error that we have on the ground truth, and the text analysis methods will only get as good as the quality of the data we give them to train against. So one thing I always wanted to do for like the last decade was trying to contribute to working on sentiment analysis using annotations by the authors of texts rather than by people reading, and see how well the typical methods we use could do in that situation. So we found ourselves in a privileged situation because the recent developments in sentiment annotated data have produced a very large data set of individual, like author level annotations from a particular platform called Vent. So Vent is a mobile app that you can use to talk to people about your feelings, and you go there to vent your feelings and get some feedback or some support, to also network with people and have kind of like a diary. And there, everyone who posts something annotates what they write with a mood label that everybody can see. So before you write anything, it asks you how are you feeling. You have a set of options. This is expanding and complicated and not necessarily based on psychological research, but at least there's a stable set of moods that can be mapped to 4 basic emotions that we know from text analysis before. In particular, we have sadness, anger, fear, we have joy or a high arousal positive emotion, and then we have a new one, affection, that we haven't really studied much in the past, and we're also wondering whether we could make a model that predicts affection as kind of a social oriented type of a positive emotion. I mean, I just mentioned that especially because differentiating positive emotions in text has been pretty rare in the past. I wanted to make that example here of differentiating affection from just expression of joy that could be a bit more selfish. So we have this Vent dataset that is from that platform. So we have several million posts. The full dataset is about 30 million, but then when we focus on those 4 clear annotated emotions, we end up having about 6 million. And so this is so much data that now we can have several tests of the generalizability of the model. So instead of having the typical split in a test case and a training set, we have several test sets. One is the typical random sample of texts that the model hasn't seen, but we also take another random sample of users and remove the users completely from the training set and see how the model generalizes across users. And we also take a period of time, the last 10% of the time, and then we take it out to see how the model generalizes over time. And we do this because we know that some users are very active and they could be a problem that skew the statistics and the models only learn the very active users and not the niche ones, or that there's some periods of time that have pretty prototypical types of emotional expression like Christmas. So we try to see if the model is able to generalize across those 3 texts. Then we have some out-of-domain data sets that we also use to evaluate the model, because our idea is not to use it for more event data. We want to use it especially with platforms like Twitter or instant messaging. And we went into the literature and selected data sets. So emotion labeling is relatively rare, and even more if it is by the author of a text. But we found in particular the ECR dataset is quite a standard in psychology, and the SEMEVAL one in computer science, but there's some others that are even produced also by the authors of the text, like tech is one from Twitter annotated with hashtags of emotions. So we have 5 out-of-domain tests. The samples are not the representative of emotions. None of them are. They are all different types of tests, but at least let's us see if our model is able to generalize emotions, not only in Vent. So the approach is the typical one. We have a unsupervised model for like BERT tweet that was trained against Twitter. I guess that later we'll also hear more about that. We contributed also a bit to the methodology because we made what is called emotion-aware masking. So part of the pre-training of the model, when invert usually is trying to guess words based on the context. So it masks a word and tries to guess it. And we can prime the learning of the model by making it more frequent that it has to guess words that appear in a lexicon of emotional words. So in the pre-training of the model, there's an additional effort to learn and to infer emotional words from the context. And we noticed that improved the quality of the method. I don't go into a lot of details, but we get about an improvement of 5% of the total performance we have thanks to that. So we try to contribute a bit to the methodology for the first time, and we show that at least this current trick is helping. So then what we did is that we fine-tuned to predict these 5 emotions. So we have anger, sadness, fear, joy or happiness, and affection. And then we compare against the typical benchmark of models, supervised and unsupervised ones, so that we make an in-domain evaluation in these 3 test samples that I mentioned, and out-of-domain evaluation in other 5 samples. So what we use in terms of data, just to be a bit more precise, the Vent dataset sample, we have the trained dataset that is about 6 million. We have the development dataset that we used for testing these ideas of masking and so on, just to select what we want to do finally in the model. And then once we finish the model and we have our final model, we evaluated it in these leave-out samples of random users that were not included in the training, a final period of time that was not part of the training either, and a random subset of the posts in the training period. So the out-of-domain validation is not as large as Vent because it's not produced by a platform with these annotations. So we focus on the typical, on the test data sets of those data sources. So they also have training and so on, but for sanity reasons, we focus only on the test data sets because we have used them in the past also ourselves. So we want to make sure that we only use test data here. And what we get in the end is that, of course, if I'm presenting this to you is because Leia, and that is our model, does the best. We have in all 3 test samples, it's outperforming our benchmarks that are supervised and unsupervised methods in terms of F1. So that's a measurement that goes from 0 to be terrible prediction to 1 being perfect. Of course, we don't get to 1 or 100%. We get something on the range of 70%, 70 or 0.7. But when we compare to more typical methods, like especially a support vector machine that is still trained with the same data, we have a change of about 10% of the F1. So the results is that our model, we call it Leia because it's based on embedding. So and I can talk about that later. Why do we call it like that? Is we have linguistic embeddings for the identification of effect, and then we have an acronym for that that is Leia, inspired by Princess Leia, but it's a bit of a Star Wars pan among NLP people in sentiment analysis. The message is that it outperforms our benchmark and it does it across emotions and across samples. So it's not that it's overlearning some type of users or some period of time or a particular emotion. It's actually giving us something that is comparable across these dimensions. And then in terms of the out-of-domain samples, so here the model has never seen any of those samples. Okay, maybe the pre-training of Twitter data did see some of these, but not the labels. And we compare the benchmark with our model, and it is either the best or tied with the best compared with the benchmark. I mean, we don't train anything with those out-of-domain samples. We only take the test data. And we see that in some cases, for example, ECR, that is something that is very clean and produced in psychological research. It has an F1 that is comparable to Vent, or Semeval, that is one typically used for competitions and benchmarks in Twitter, is also quite good. And there's some others like Go Emotions and Tekken, which is not that good, but we also know a bit of the reasons why, and is that, for example, annotations of fear in tech is a bit tricky because this means that people are using a hashtag, I'm afraid of something, and it's not as similar as what we would call an actual self-annotation of fear. So overall, we're relatively satisfied with how it generalizes across domains. We think that this is thanks to the pre-training and the large data set we're using for fine-tuning. And we made the model available actually yesterday, the last version of the model. And we're working on a preprint. So this, what I'm telling you, is really new information we never really posted yet, but by the end of the year, we'll have a preprint explaining the results. And we think we're getting to a model that we have some preliminary results, but we see that it even performs better than mechanical torquers when annotating events. And we still don't know if that's a statement about our model being very good or mechanical torquers being terrible. So we're working on it to see to which extent can we compare this with humans. So that's what we do with text. But now I want to explain you how do we apply this to study collective emotions. In particular, when we study collective emotions, we want to do something like have a macroscope, like a loop that we can apply to the whole world or a whole country and track emotional expression over time, applying, for example, a model like Leia to a lot of tweets. And for this, we can do many analyses, like whether emotions spread in a network, whether they change across regions, or whether they move over time in a place. And we can see, for example, the effects of the pandemic or the effects of collective emotional situations, like it can happen also spontaneously. And this idea of using macroscopes to study emotions is not new. It's basically about a decade old in computational social science. I have used it myself. For example, in a paper in Psychological Science a few years ago, we were studying collective emotions after the terrorist attacks in Paris, and we studied text in tweets. This wasn't as advanced as Leia. This was the very simple dictionary method of look. But we saw a reaction, it fit theory, and so on. So we were satisfied by it. But over time, I started thinking this is not as valid as I thought. First of all, this sample of users is not representative of the French society. So there's an issue of representation, and we don't know if the people we are using are good as a sensor for emotions in society. Second, there's also performative behavior in social media, and we know that they might not be genuinely expressing what they feel, but something that is useful for some reason. There might be measurement errors, like, look, we know that at the individual text level is not very good. The aggregate is depending on the situation, but there could be biases working differently for different groups of people. So also the error induced by sentiment analysis is a bit of a concern. And finally, there's a lot of researchers' degrees of freedom, and you have hundreds of different sentiment analysis methods you can use. And even if they're completely random, with a sample of time like this, you will eventually get one that works the way you want. And it's also important to try to clean things in advance and know what you're doing rather than just trying things out and cherry picking the best results. So I wanted to test whether it is possible to measure emotions of people over time in a country with social media data. So for that, we designed a study and we pre-registered it to try to limit our degrees of freedom as researchers. So what we did is that we compared what we can measure through Twitter with a representative panel in the UK made by YouGov that it makes measurements of the frequency of experience of emotions per week. So they have a rolling panel per week, and they really ask how much or how did you experience this or that emotion over the last week. So you have that rolling window of frequency of people who report in having experienced a particular emotion. So they have a list of 12 emotions, but we don't have good methods to measure them on social media text. We focus on some for which we had a good prior of text analysis methods. In particular, sad, scared, and happy are ones for which we had some methodology. So what we did is that we went to Twitter, got all the tweets we could from the UK using Crimson Hexagon that allows us to make samples of tweets by country. We filter the geography, we apply gender detection to rescale because we have double the number of tweets by men than by women in the UK. Not double number of users, but double the number of tweets. And then we apply the text analysis. At this time, we didn't have Leia yet, but it's relatively similar. We're comparing dictionary-based methods because we thought that let's see if we can put the last nail on the coffin of dictionary text methods and see how do they behave here versus a more advanced method. Okay, so the idea is that we have two time series we want to compare: weekly rates of experience emotions of these three emotions and gender rescaled indices of emotional expression based on tweets. So we want to correlate those two. And the actual statistical test is tricky. You can just do a cross correlation analysis, but the null correlation is not really zero because these time series are autocorrelated. So there's a variety of time series methods to do that. One is called the trended cross correlation analysis to try to correct for that. So we pre-registered this back in 2020. So we have a historical test of all the data that was available before, kind of like a pilot, and then a prediction of what should happen afterwards. We will update the results eventually, but we have several months after we pre-register as a real prediction of these two things should correlate. So we have, again, sadness and scared and happy, and we want to correlate two time series for each of them. So here are the results for sadness. Again, these are weekly measurements. In red is Twitter, and in blue is YouGov from the representative survey. And over time, we see that there are spikes of sadness. There's one here that is related to some elections that were pretty relevant for Brexit. And then we have also the pandemic, how it started, and it created a spike of sadness that took a while until it relaxed. Then we have a bit of a downtime over Christmas and so on, and then it starts to oscillate. So if we compare these two time series, just the basic cross correlation in the historical period is about 0.7, and in the prediction period is similar, is not statistically different, 0.65. So overall, there is a substantial correlation. Of course, it's not 0.9, but it's missing some peaks, so this is a bit of a lag. But overall, the main dynamics and whether there is a peak or not on a period of time is relatively similar, with some notable exceptions. For example, this peak here that we see on Twitter is absent in the survey, and that's actually the Ferguson case in the United States that we could see in the expression in Twitter, but not in the survey. So it also shows that not all Twitter data is the same, and perhaps we can clean some of these political signals in the future. So for anxiety, as like expressions of fear in particular, we have quite a spike, particularly at the beginning of the pandemic. I don't show all the details, but it's higher for women than for men. And actually, if we don't rescale by gender, the correlations get worse. And the correlation coefficient in the historical period is 0.78, but is quite driven by this particular spike. So it's not what we will call a very linear correlation. It's not against it, but is inflating it. And in reality, something about 0.5, which is also what we see in the prediction period. So there is some signal also that we can measure with social media with respect to anxiety. And positivity or joy is a trickier one, because when we use the dictionary-based method, for example, look, is terrible, is completely uncorrelated, and we actually could expect the worst for this case from previous research that shows that the positive dictionary is not very specific, and it's a bit too general to actually capture positive emotions in social media. But when we apply a Roberta model trained with Semeval for joy, it actually correlates a bit better. It's something like 0.6 with, again, the same typical spikes and drops that we saw over the pandemic. So we get, again, a similar correlation of about 0.6 if we use supervised methods for joy, but if we use the dictionary method here, it didn't work. In the other cases, supervised and dictionary methods were similar, but for positivity, we noticed that dictionary methods did not really work. So we replicated these results. Well, we reproduced them. We did it again, but in another case, because a newspaper in Austria was running an online questionnaire asking people how they feel for 20 days in Austria, whether they experienced positive or negative emotions the previous day. And we worked with them, and we made it really an analysis over 2 days of all the historical text data of interactions on the website of the newspaper and correlated with the answers they were getting in the survey. So we didn't have any time to massage the data. So we just had an observatory already ready for us, and we just had to correlate with whatever the newspaper sent to us. We did it so quickly that we didn't even have time to pre-register the hypothesis. It's a pity. But at least we could test our idea if it generalized to now higher frequency is not so long, not several months, it's just 20 days, but at least we have daily frequencies. There's a bit of a smoothing required, because the actual what means yesterday is tricky if they ask you at 1 a.m. So there's a maximum resolution of 3 days. But when we compare those two numbers, we get a pretty high correlation with what we see in German after applying German sentiment analysis in the discussions in the newspaper and what people feel, or what they report that they feel in terms of positivity and negativity. Actually, the lines are so similar that when we take the differences rather than the levels, we also get a correlation of about 0.76. So we see that we are measuring not just the level of emotions, but also the dynamics and how they change over time. And here we have a sample that is not representative of society. Again, there could be many reasons. We know that, for example, there are more leftist and more liberal in this newspaper. But when we see reports by the same people that are writing, we get a very, very high correlation when we compare text with surveys. So it might not be so bad to use social media data this way.
David, I'm sorry.
Am I much over time? Yeah.
We started late, so I think but if you could, I think you're
I'm almost done. Okay,
Ah.
I'm wrapping up. Yes. So just, I think that when we're using these methods, we're not measuring necessarily only the individual emotions of people, but also the emotions of people in their environment. And they are also talking about what others feel. And that's why perhaps is working against representative samples, even though the samples we use are not representative in social media. So emotions might be different than opinions in this sense. And some of the concerns that we had for opinions in particular might not be really that strong or that important here. So just summarizing, yeah, we had important concerns about social media data analysis methods in terms of representativity, but for emotion macroscopes in social media, they substantially agree with more traditional social science methods. So we have some preprints, and we also publish this a summary of this in the World Happiness Report. So we don't want to replace surveys in any way, but I think that for faster frequency or for places or countries where we can't run a survey, but we have social media data, it might allow us to study collective emotions in a way that we couldn't before. And yeah, just summarizing, I wanted to study collective emotions. So I showed you two important methodological building blocks for that: social media text analysis and how we use that to track emotions. So I didn't say much about the collective emotions themselves, more about the methods. So in the future, I will show this. And if you want to learn more about my work, follow me on Twitter, if anybody still uses Twitter, or just check my website, thegarcia.eu. Thank you very much. Looking forward to the discussion.
Thank you very much. And clap in the way you like. And thank you, David. That was really fascinating. I mean, these correlations between these different sources of data and how and the F-scores of your classifier is amazing. I invite specific questions about this talk if anyone wants to jump in. And while you're finding your buttons, I just wanted to ask, could you talk a little bit more? I know you thought about it, about emotions that are specifically kind of collective. And this is relatively like a new, maybe in all the new area. You mentioned, for example, affiliation, feeling of affiliation or kind of liking of another person. But there are also things like we all feel now that the World Cup is going on, like national pride, fear of the out group, devotion to your group, this kind of. Is there, do you think there is a promising framework to study these things, and would the classifiers also be able to detect those?
So with the case of affection as not more collective, but a more socially oriented emotion or socially motivated one, we can distinguish it from a more joy that doesn't really get directed to someone. But still, that's a bit different to the question of like group-based emotions or emotions that you feel for being part of a group. And it's also different for the question of collective emotions that might be a more simpler emotional state that people share without even necessarily knowing why. So I think we're getting closer to having methods to detect also these more nuanced feelings rather than emotions. But I think for the study of collective emotions, we're usually in a simpler situation of basically positive, negative, or differentiating negative, but looking more into actually what are the contexts of each of emotion or aggregating into a feeling, we're still a bit behind on those methods. Yeah.
No. Okay, thank you. But it's fascinating already what you have. Really. Rob.
Yeah, so this is actually a follow-up on Merce's question, but maybe even a more extreme version. So when I hear collective emotion, I think by analogy of like collective cognition or distributed cognition, and like sort of the Ed Hutchins case where the cockpit or the ship is navigating even though none of the people might be navigating. And so I'm wondering about whether you think that ever occurs for groups, that like, I don't know, a company might feel fear for a competitor company, an upstart company, even though the CEO doesn't feel fear or none of the people in the company feel fear. And so I'm kind of wondering about how that would match on to your sort of more individual specific ways of measuring sentiment.
Very interesting. So here, when I'm talking about collective emotions, is basically a phenomenon that exists, but is still building on individual emotional experiences. So it's not like an organization behaves in an emotional way, even though nobody has an emotional state. It's a bit different from this kind of collective psychology of Gustave Le Bon, of like there is a feeling of a group of people and it operates as some sort of meta structure and so on. I think now the research has gone more into a complexity science approach of saying there's people and there's interactions between them, and the collective state is built on top of the individual states that are not as simply describable, because you also have to take into account those interactions. So I wouldn't say that nobody's emotional. They are in the case of a collective emotion, people experience an emotion and they should be able to report it if you are able to ask them. The question is whether that experience of emotion changes substantially because they are in a group. And there's different cases. So there's the one that is more similar to that emergent case in which you have a group of people and there's no trigger for the emotion. It's just happening because they're together. I think the example of a riot from Mark Granovetter's model is a good one. Nothing happens, but then still a wave of anger that turns into a riot. While in other cases, it's more triggered by something and it's more trivial, it's less collective, so to speak. It's more interesting when it's driven by the people rather than caused by something.
Thanks.
This was really, can I ask? This was really interesting. I really enjoyed the talk. And I see that in your approach, you sort of want to show that these different methods, they sort of give you the same sort of results. But I was wondering if sort of flipping that question upside down and asking where and how these things sort of differ so that social media doesn't actually represent reality and it has its own dynamics. Will that be a worthwhile line of inquiry?
Oh, totally. So I think here I was starting from a worse situation, saying like, I have a crisis. We don't know what we're measuring with social media. Let's give a number to how bad it is. And the number didn't sound as bad as it was. But now we can start from that and see when is it not working. And we noticed some examples, like the case of Ferguson was not appearing in self-report, but still in the text. This doesn't mean that people in the UK that don't feel it, but maybe it's only the ones who use Twitter and might be closer to the news on the UK. So the differences are very interesting, both for cleaning the methods, if we really just want a representative signal, but also for understanding internal dynamics on social media that don't happen offline to kind of separate what happens offline. We've done this in some research in which we want to kind of remove what happens in the rest of the world, and we have like a seasonality terms that we remove. But I agree. So differences are very interesting. Also, when we look at demographics like genders, and that we go a bit more in detail in the World Happiness Report, we notice interesting gender differences that point to women being affected by the pandemic more than men, for example. So I think the error is a research topic in itself and not necessarily a problem.
Thank you.
Thank you, fantastic. I'm sure there could be even more discussion, but now it's time to switch to Rick. Rick, please take it away. Thank you very much. And thank you, David, for the interesting talk.
All right. Can everyone hear me okay? Can you see my slides? All right. Just to confirm, you don't see my presenter mode. You see the complete slide. It's all good. All right. Thank you. Okay. So I'm going to present on something that's relatively new. I think the provocative breadth of the workshop offers an exciting opportunity to delve a little more deeply in some new work with a new graduate student, in fact, Zachary Rosen, who led some important parts here that I'll summarize, including some other students and collaborators who I'll mention along the way. So any errors are my own. The talk is going to orbit a particular kind of computational object that David actually used in part, and some of the methods there. And it's somewhat casually known. If you're not familiar with this yet, you may see this mentioned in various places in social media and so on, because it's certainly become part of sort of public consciousness, these tools. And so large language models. And just for time, I'll simply state to begin that these are essentially just very massive neural networks with many layers that utilize a learning algorithm that's been optimized to extract meaningful features from huge amounts of data. And you can use these large language models to do a variety of things. You can train them on different things, for example, emotion classification, as we just saw, or even simply text generation. So these models, I'll show you an example of, in fact, BERT, related to the one that David used a little later. But I just want to begin by showing what these models are capable of course. And I think many of you have probably seen this, but I found it fun to start a talk at the Augmented workshop with an example of asking GPT-3, which is one of these very large scale models. This is a task it's been trained on completing. So you can ask it a given question, such as, let's see, let me move this out of the way. Okay. When you combine technology and the human mind, how do you get augmented intelligence? And these systems behave surprisingly coherently. It's a combination of human and machine intelligence to create a more efficient and effective system of problem solving. I don't think this will solve any problems that the workshop is seeking to solve. So you won't have to, but there won't be any shortcuts either. Now, these models are pretty interesting, of course. They have linguistic knowledge at various layers of abstraction. So you can ask it to answer the question in a very specific stylistic way, such as answer this question in a brief poem. So I liked this particular one. It's a little bit clumsier. A powerful combination of tech and the mind, augmented intelligence comes to find, able to extend our abilities far, innovative power to create and not mar. So yeah, there you are. Now, these large language models quickly descend upon these topics of the workshop. And my favorite that I have yet to try, that I'm very excited to try, I don't know if I'd be very interested in hearing anyone's impressions of this, but GitHub has trained a model using exactly this sort of system that's been plugged into these new architectures. They refer to this as GitHub Copilot. and it's been trained on a massive data set of code and language. And Copilot is meant to be a kind of coding copilot that travels with you. It's a plugin for your code editor. You can give it instructions and sample data, and it will actually carry out some simple coding for you in order to generate some simple functions and so on. And some feedback I'm getting from friends who use this suggests that it's actually quite workable as something that accompanies your work by solving some of the simple problems so that you can focus on the bigger programming problems that you're working on. Now, for us in Augment, though, and for me as a cognitive scientist trained as a psychologist and as a linguist, I'm interested in the way that these large language models can be deployed as a tool, but also potentially as a kind of theoretical construct for understanding what language is. And of course, there's a number of statements about this popularly, but also in various literatures as well. So for example, recently, Pablo Contreras-Collins and a co-author wrote a conversation blog post arguing rather forthrightly that these models are actually, if we had done these models 20 years ago, they would have been published in Cognition or Cognitive Science, and we would have called them incredibly successful evidence that in fact experience is sufficient for extracting considerable structural information about language and so on. And so in this particular piece, they suggest that in fact these models are evidence that their incredible structure can be extracted by these systems. So I've just introduced you to these kinds of models. I'm sure most of you have probably seen these, but for me in the work that I've done in the past with collaborators and students and so on, we've focused very heavily on trying to understand maybe what could be called the augmented intelligence context of interpersonal processes, of people having interactions in various ways. And so this might relate, for example, to Natalie Sabanza's talk or Mike Richardson's as well. And so in our prior studies, we would bring participants into particular circumstances. They might do this through Zoom nowadays, of course. And we find ways of just very simply extracting various signals from their behavior. And recently we reviewed this prior work and connected to other work as well. So with former PhD student Camila Alvear, she's now a postdoc at Vanderbilt. She summarizes this work in a recent review with us. And we summarize a couple of ways in which we've tried to tap into this augmented intelligence system, namely two people sort of formulating a kind of coherent system themselves. One way in which you can do this is to extract a multimodal signature from participants. So even from a video alone, you can extract various characteristics of speech, body motion with some other simple tools. You might even get, so for example, social eye movements and so on. And one method for discerning what's taking place in the system as it's dynamically changing is to use various machine learning techniques like dimensionality reduction and so on those multiple signals. Another method that we've used to analyze these kinds of signals, especially nonverbal signals, is you can extract simply a single time series. And you can do various kinds of dynamical analyses, machine learning techniques to actually make inferences about the underlying system, even from a single time series. And just to give you a quick summary of what we've found and what's challenging in this particular area from an Aug-Int perspective is that participants are, pairs of people are highly adaptive. So this would relate to Myrta's talk, for example, and you can see, for example, interpersonal processes being little networks themselves as they're assembling these components of nonverbal behavior and the way they weave together, and Rob's talk on roles. But what we find though is there's a considerable labile nature to these processes, and it depends very heavily on task and context. And so the way in which participants are synchronizing or taking turns or using their eye movements and so on will depend upon potential perceived goal, social groupings, and so on. And this is what we've generally found in that particular work. But I want to tell you more about the large language models. And so there's a long-standing concern about doing exactly this kind of thing in the interactive context, but to look at various layers of abstraction in language to understand how linguistic elements are being used during interpersonal processes. And in particular, there's a prominent literature, of course, trying to extract meaning from these. And incidentally, several workshop participants have contributed substantially to this agenda, like Danielle McNamara, who's here today, and Mark Stivers, and so on. And large language models are an instance of seeking to extract meaning from these interactive circumstances to figure out what's going on in the informational exchange. So I'm going to tell you about a particular application of a large language model, taking this large-scale system that's been pre-trained on a huge amount of data to extract meaning and then apply it in a highly flexible way to various domains of interaction. And after David's talk, actually, Zachary and I, Zachary's published on this already in the Journal of Language and Social Psychology, but we've devised led by Zachary, a computational framework for using one of these large language models to get at meaning in a new way, so that we can quantify those interactions at a more abstract layer. And so after David's talk, we're looking for a name for this, and I think we might want to name it something like language unpacking with known embeddings, or Luke. And I think David's laughing, so I think this is pretty good, right? Anyway, thank you for that suggestion. I'll have to take that. So we're using BERT, which is an architecture that David used as well. So it's a nice correspondence there. And BERT is basically, it's a large language model. It actually can be understood simply as, in a very simple way, what it's seeking to do is identify meaning as a string of numbers, as an embedding vector. And so, for example, the word dog might be simply a string of numbers, an embedding vector. And of course, BERT is a multi-layered neural network. So it actually we're using base BERT to avoid some of the things David was mentioning in terms of cherry picking and so on. We simply use the base BERT model. There are 12 layers of these. We use a couple of layers, but there are some details there that I'll just skip over. But what's unique about BERT, though, it's doing what latent semantic analysis has been doing for some time, and other kinds of methods as well, as it's seeking to quantify word meaning by identifying a word's meaning as having a particular coordinate in a high dimensional space. But what Luke is especially, Luke, that is the model, I guess. What BERT is especially good at is embedding and modulating these embedding vectors, these numbers, according to context, also in both directions as well, both what's ahead of the word or what came before a given word. And so you're getting highly conditioned embedding vectors for a given word that you can then analyze by sending BERT samples of text and seeing the relationship among the different words that are being reconstructed by BERT. And so the way this particular modification of the model works, and this is due to Zachary, I'll try to summarize it here, is we can extract the embedding vectors according to a subset of texts. We can then basically extract a kind of probabilistic representation of those embedding vectors by essentially using a kind of cosine metric and converting this into a probability distribution across two different types of text. So basically we have a target text that's going to be recovered by a context or a background text. Can you see my mouse? I don't know if you can see my mouse there. Okay, cool. And then what we do for a pair of texts is that we can obtain a kind of entropy score that reflects the kind of recoverability of a given piece of text relative to some context. Now you can imagine just from that description, I'm hoping it seems evident at least that we can adapt these models then to apply to conversation, because then we can apply them dynamically, because what I'm saying now is part of the context of what I said before, but in conversations that we are the temporal context of each other while we're conversing. So here are a couple of research examples using this kind of model, and it's highly extensible. So here's an example of what the code would look like to run this model on just a pair of texts. So Zachary's really optimized this methodology to be as simple as possible, utilizing what's called the Hugging Face base BERT model. So you define a couple of classes, objects, and then you're sending them a pair of texts. But this is just the generic framework. We can apply it in a variety of ways. For example, we can look at the extent to which an individual person's text is recoverable from some social group of multiple individuals who have many texts that bear upon it. So here's an example application of this. And this is something we've just submitted in a methods paper summarizing this particular approach to using BERT. So Zachary extracted from 538 a subset of tweets on a particular political issue using just a small subset of keywords that all these tweets contain. And this is a relatively small data set. Sorry, it's only a few hundred tweets, really. So it's a very noisy, small data set. And it's organized by a political party. These tweets were issued by official members of Congress, and that's why Zachary chose them. And the basic idea is that there is likely a kind of recoverable rhetorical structure to this communication that's taking place across this group of individuals, such that, for example, on the backdrop of other Republican tweets, each individual Republican tweet is likely more recoverable compared to, say, on the backdrop of Democratic tweets. There should be a relationship across these particular tweets. So the way the analysis works is we take a subset of those tweets, we remove one, and we simply seek to recover and obtain that entropy score for each individual tweet separately. And then we can obtain this 2x2 kind of analysis where you have the context, the Republican context, for example, here, recovering Democratic tweets. And then we can do that for each individual Democratic tweet and then obtain an average entropy score. Now, if something's highly recoverable from the embedding vectors, then you would expect low entropy. It's not very, it's not very surprising. It can be recovered. Something that can't will have higher entropy. So these are the basic results as a sort of proof of concept in very noisy and small data set. So here I'm going to represent the tweeters, the individual tweets, and they're the target, and they're going to be recovered by the context, which is Y here. And so we get some very robust results even in a relatively small data set. And it raises interesting questions about, for example, potential collective messaging strategies of groups that are more or less or relatively coherent and can be recovered more easily or are mutually predictable relative to each other. So that's one example. Another example is that we can analyze texts across time, as I mentioned a moment ago. So for example, Zachary and I are now analyzing some identifiable changes to political discourse on subreddits. And we're looking for the introduction of new concepts, and we're seeking to use this kind of technique to quantify the way in which the broader semantic space changes as particular pointed political ideas get introduced in dialogue. And so we don't, just for sake of time, I'm only going to give you an illustration of this, but we can do a couple of fun things. We can look at the extent to which the group is becoming more recoverable and coherent across time, because we can apply this temporally. But we can also look at how the existing group members who've already been part of the dialogue help to recover a new member's messages or comments on the subreddit. So we can look at the sort of overarching structure of the group, but also dynamically how it appears to have emerged in terms of their rhetorical structure. Finally, I want to show that we can also do something that Zachary's currently calling it a sociosemantic graph. So we can take a batch of texts, do all pairwise comparisons using this kind of recoverability method. And so for fun, I thought it would be neat to take the abstracts from Augmented and use this recoverability analysis, use this Luke method to do the pairwise comparisons across your abstracts, and mine too, mine's in there as well. So for example, when we use Danielle McNamara's, and suitably, hello, Danielle's here, to recover David Sumter's abstract, we actually get the highest entropy here. So the notion here from this large language model is that there may be more conceptual distance between these two samples of text. Now, David's abstract also happens to be part of the most recoverable pair, namely between Sumter's abstract and Cody's. So this is relatively lower entropy. So what I did for fun was I took so there are 41 abstracts there on the website, and I wired every one to their closest neighbor on the semantic landscape, and then projected the plot using a force-directed algorithm here anyway. And here's the Augmented workshop so far, at least. You find potential hubs, maybe AI, maybe human factors or human AI teaming or something, definitely with Mike Richardson's talk, for example. And then maybe we have clusters that are related to other important topics about education and science policy and so on. Anyway, of course, I have this very critical hedge down here that says tentative preliminary first pass. But in any case, the idea of this technique, of course, is that we have what others are referring in other domains, to an AI system, but we're utilizing it in highly flexible and extensible ways to analyze these communicative processes in a variety of contexts, finding that because of the extensibility and the flexibility of these kinds of large language models, we can analyze a wide variety of domains in these interpersonal processes that we're interested in. So in terms of Augmented, it seems that my main interest, of course, would be to convey the potential for these kinds of methods to elaborate on the augmented intelligence that derives from a couple of people interacting with each other, or small groups of people interacting in particular circumstances. And that's true. I wanted to show that. But I also wanted to end on a broader point, because in collaborating with Zachary and learning about these models, and I should note I'm very early in stage of my understanding of these models, so it's exciting to give this. It's the first time I've talked about it out loud to a crowd, at least. Is thinking of these methods as actually coupled technologies to us. In fact, we ourselves, as the scientists interested in Augment here, we are also illustrations of these kinds of deep and important questions about augmented intelligence as well. And so across the history of analyzing, say, language, especially language in context, there have been a variety of methods that have been used, and we can see what we're doing as scientists is becoming coupled to particular kinds of technologies to accommodate particular limitations in our perceptual or cognitive processes. This, of course, relates to the accommodative kinds of results that Mark finds in his nice talk. So, for example, if you'll allow just sort of this playful historical reconstruction of only a subset of the methods relevant to this kind of linguistic analysis, long ago, maybe the first and important methodological technology introduced to codify these kinds of analyses of language and how they relate in context and use has been coding schemes, and using pencil and paper in order to have carefully trained individuals create data banks on paper that can be pored over and analyzed and so on. These kinds of methods still used in various coding domains, now, of course, supplemented by various software. But now the emergence of tabulation and personal computation and so on allows us to carry out much more aggregate analysis of these kinds of processes. So we have some computation getting a little bit more complicated and participating in this endeavor to quantify language in context. And so, for example, this probably found its best expression in Doug Biber's work on the analysis of natural language in English and English conversation and so on, doing extensive tabulation across a wide variety of contexts and genres to characterize them and analyze them in interesting and various ways. In the 90s and early 2000s, and still used widely now, is maybe a little bit more computationally sophisticated, of course. Now with the availability of larger scale data representations and so on, this equation here is a very simple little proposition here is likely familiar to several of you. Singular value decomposition of a term by document matrix is, of course, the core of latent semantic analysis, which is arguably probably at least in cognitive science, still the most prominent way in which to obtain vector embeddings of the meanings of words. But now we do have these large language models that are arguably highly flexible, highly tunable. You can fine tune them in various ways and so on. They're arguably AI that's actively becoming integrated with our research itself. We are participants with an integrated technology already. We are maybe the best subjects for the workshop ourselves. So the purpose of showing you these examples was to show that in very simple ways, we can take this technology, and it's not simply a simple probe. In fact, it's something that has to be tuned and adapted to the given context, despite the fact you're using the same pre-trained set of knowledge, but you're using it in a wide variety of ways. And in doing so, we are sort of engaging in this active integration of technology and investigation in order to mitigate among various theories that are trying to explain the phenomena that we're interested in. So just a couple more slides here and I'm done. So these models have fundamental limitations, though, of course, so it may in fact be best to think about this, much like Stiver's talk as well, to think about these kinds of tools when they're integrated and so on as having particular kinds of concerns or limitations associated with them. So there are considerable model limitations in these large language models. It is very easy to find edge cases where they sort of they don't have the complexity or the fine tuning in their feature space in order to give you an adequate response. In fact, there are some demonstrations of some simple versions of these large language models where you can get some questionable results. There's a really interesting paper called Unnatural Natural Language Processing that does some permutation over sentences and shows that, for example, some of these BERT-based models can actually assign a high probability to very ungrammatical elements. In any case, there are also substantial ethical concerns that are associated with this as well. And so this is a very interesting domain, surely, that this is something that has been discussed and will in the workshop going on in terms of how, so for example, even GitHub Copilot has run into various kinds of intellectual rights issues because it's utilizing the gigantic data bank of other people's intellectual efforts to generate code. And yet here it's being monetized as a way of helping everyone with their code. So it yields interesting questions across a variety of domains. So I'm just going to advertise a new paper that just came out with Anne Werlemont and Carrie Johnson. We argue in a Nature Review Psychology paper that method is fundamentally important to theory in some potentially interesting ways. And so we explore this in this review article. One way that we articulate in this paper, and is fundamentally related to Augment and large language models, is we draw from some classic concepts from the domain of cybernetics, self-regulating systems. And we describe how the methodologies that we deploy in order to become coupled to the phenomena we are interested in ought to be concomitant in the complexity of the phenomena themselves. And so language is we use language and communication as an example in this paper, but it's a highly complex, multi-layered system across several timescales. And so we argue that any science of phenomena sufficiently complex ought to have an array of methodologies associated with that investigation that should be concomitant with it. So the law of requisite variety is this idea that in a self-regulating system, the number of states or distinctions that system can make should be equal to or greater than the number of environmental perturbations that it may face, right? And so as scientists, we are looking for new sources of variation that are constantly perturbing us and seeking explanation. And so looking to more and interesting complex technologies to couple to will help with this. And so the large language model case may be very interesting because and this is where it relates to the potential coupling of AI as well, is that it may contain, so the use of a specific method such as this one may contain sufficient complexity or variation in such a way as to satisfy this law of requisite variety, despite the fact that you're using simply a singular potential model, in which case we might be legitimately thinking of ourselves not as necessarily scientists with a method, although that's really what we are. These are tools, right? But it may be theoretically provocative and interesting to think of ourselves as now being coupled to measurement schemes that are now becoming so sufficiently complex to be called human AI coupling already. We're already doing that. So in interpersonal processes, we have high-dimensional agents in a very indeterminate problem space. So large language models might help tease it apart. And in augmented science itself, we have high-dimensional subject matter, but often with an indeterminate problem space as well, which is quite different from some of the prior talks as well. And so using these kinds of flexible new AI systems, they have some key limitations and so on, may nevertheless be a source not only of great models, but, and as illustrated in David's talk as well, as critical sources of measurements for adapting to and working with new and complex problems. All right, I'll end there. Yeah.
Thank you very much.
Was my mic on? Oh, yeah. All right.
Thank you. That was really fascinating, the way you're using these large language representations for really innovative analysis that I think have not been done so much. So that's really great. And while people are finding their buttons, I'm curious. There's a couple of clarification questions because it was such a whirlwind. Maybe I didn't catch all the details. So when you mentioned that you recover one tweet from a group of tweets, does this mean that you basically take vectors of other tweets and try to predict that one using some sophisticated neural network or regression?
Yeah, it's actually the algorithm. Yeah, I hesitated on how much detail to give on that particular slide, but it's actually quite simple. It is using BERT, so you're presenting the sequence of text to BERT, and BERT is generating embedding vectors in response to that sequence of positional words. Mm-hmm. And in that presentation, what you have is context, which precedes your target words. And so what this analysis does, it actually takes embedding vectors, in fact, from layer 8 and layer 12, which in the natural language processing pipeline that BERT seems to implement possibly, has some of the more critical ingredients of meaning that we're interested in. And what this algorithm does is it looks for maximum cosines across pairwise words. And the idea being that when you have higher cosine, you have higher relationships among meaning. And so when you have a very high number of, when you have very high cosine assigned to all the pairs of words that you can possibly compare, it means that the meaning has essentially been sort of reconstructed from that context. And so it's very simple. It's just using cosine comparisons of vectors. It's just using the output of the neural network. I hope that answers the question, but try to give it a brief.
Yeah. And related to that, I was really intrigued by the result which you show with Republicans and Democrats and trying to predict tweets from each other. And then for Republicans, somehow you got bigger entropy for Republican tweets. Do you infer, and then the Democrats got for Democrat tweets, do you infer anything from it? Are they having a more diverse discussion than Democrats?
Yeah. I think that we are seeing this as a potential technique to be coupled with others because, for example, we do carry out some controls to ensure in the various analysis we've been doing, just to make sure it's not simply repetition. But nevertheless, some of these recoverability characteristics may be driven by, for example, just very repetitive messaging, right? That can still be captured by the method, but it could also be captured by conceptual relationships across words. And so the plan in some follow-up analysis is to use this as a sort of data mining to determine why that entropy would be higher and lower across these different groups. It may be possible to make that inference, I agree with you. So for example, you would expect lower entropy would predict sort of rhetorical tightness or coherence across the group. But we feel the best way to do that is actually to look at subsamples of the text under those analyses just to check that that's indeed the case just from intuitive assessment. So it's interesting that we're using BERT as a data mining technique to ascertain how these potential rhetorical structures are actually manifesting in those numbers. But yeah, that is possible though.
Thank you. Great. Marina.
Hi, Rick. Thank you so much for a really thought-provoking talk. I was interested in the last part and you kind of sweep over it. So maybe I would also need some clarification, but I was interested in your idea of viewing scientific tools as interactive parts of the scientific process, kind of taking the augmented perspective on science as well in this case. And I was wondering if your previous research or some other research you are aware of could suggest particular ways that we could use to take the best out of such interaction. Is there some research that could translate and suggest directions on how we could get the best out of this perspective on science?
Yeah, I think so. I partly wanted to bring it up as well because I wanted to hear everyone else's take about how you're also sort of seeing this as an exercise in self-reflection as well, because I mean, augmented intelligence is happening right now. And so it's interesting that a lot of the phenomena that we study it's sort of the other, the participants and so on beyond. But I am eager to think in these terms. And when you say, the best way to tap, I guess, there is quite a rich domain of bibliometrics that's interesting as well. Rob's, of course, published extensively in this domain. It might be interesting to look at particular methodology terms in a bibliometric context and for example, the large language models it may be a very timely moment to look at how these methods are spreading and how it leads to an integration of fields, for example. And so I did a collaboration one time actually with Pablo Contreras-Callens, I was mentioning earlier, and we extracted abstracts from thousands of articles in cognitive science to see how the methods and the theories actually overlap richly with each other. And we're able to use various terminologies to predict what particular theories papers adopted. So it may be possible to use these kinds of methods, and in fact, doing fine tuning like David's talk on emotion and classification, but we could apply it to different aspects of a phenomenon that we're interested in. It may be possible to create these kinds of models to look at how these methods are spreading, how they're leading to integration of different domains, and so on. But anyway, I don't know if that answers the question, but that's one thing you might do is do bibliometrics like that over potential applications of techniques. But yeah,
Rob?
Yeah, great. So wonderful talk, Rick. Thanks. I'm also, like Marina, was interested in the last part of your talk, and I'm totally agreeing with you about like the fundamental importance of methods to theory, and thinking of like the cyborg coupling of the NLP tools that we're creating and are theorizing. And I guess in the negative sense, I'm worried about us collectively being like scientists who are like playing the same role as the drunk in that old joke about the drunk looking for his keys under the lamppost, even though he lost them in the bushes, because the light's better under the lamppost. And so what can we do to protect ourselves from sort of implicitly modifying our theories so that they're just satisfied with our current set of tools? Like, and to take your scientometrics examples, I feel like there's tons of work in scientometrics on scientific impact, because it's so directly connected to H-index and the number of citations per paper, when maybe we should really be interested in the importance of our theories or of our science or the quality of the work, which is much less measurable. So how do we avoid that kind of slippery slope?
With large language models in particular, do you think, or you just
both? So both of those domains, the
Yeah.
scientometrics and what is measured by the NLP.
Yeah, well, I guess I'm sure many here have thoughts about this. You too, but I know I think that, for example, in the case of large language models, at least, these I didn't have enough time to go over the limitations, but there are fundamental concerns, of course, associated with these, because when even in the analysis that we're doing, there's a certain element of trust invested in the algorithm, which I guess is the lamppost. You're sort of looking where the sort of regularities arise. And so I think a critical piece to any new methodology is sort of codification, routinization, testing its knowledge, and so on. Something I didn't mention, for example, the large language models, is that there's a veritable literature now of researchers studying what these models know, their social cognition, their syntactic knowledge, and so on. And so I think that's a critical piece of any methodological development, is to understand the sort of fascia, how it's interconnected with everything else, so we can not end up having it direct us in the wrong way. But I think in terms of the broader sense, of coupling and so on, like you were mentioning the metrics, like any metric that is known by the agents participating on a network might become a bad metric because it could be gamed. And I can't remember the name of that law. Does anyone remember the name of that law? Yeah.
Goodhart's law.
Goodhart's. Yeah. Any metric is once measured. But yeah, I know. I think that one way of it's I guess I hesitate to say this because I don't necessarily hold this opinion, but if you take like an efficient markets hypothesis, right? I mean, there's sort of the notion that researchers, with the kinds of tools that we have now, maybe allowing for some particular alternative cases, are aware of a wide variety of terrains of application and knowledge and so on. And I think that it may be possible for researchers to think instead about the kinds of efficiencies that might be present in that system, and, for example, information transmission. That's interesting in and of itself, whether something's getting cited or not. I think if a community of scholars utilizes large language models, which are now being re-imported in a sense back into cognitive science and so on, we can, engage in, a different kind of normative enterprise, and then potentially use these very models themselves to analyze these. And so I think that the normative agenda to identify the metrics and but then find them in the data as also important. It's also an important enterprise of description as well, to look at how this rumor or technology and so on is propagating over this network, is a potential way of not getting trapped inside particular metrics either. So it should be an active, I do think, like articulating these potential or quasi-normative elements of what we expect a good network behavior to look like, to be part of that endeavor as well. And it will have the kind of inescapably normative feel to it, just much as H-index does, unfortunately, right? But anyway, those are just some thoughts, but I'm sure you all might have better thoughts than those ones. But yeah,
this is great. David, please ask.
Yes, so it's not a question, it's more an idea for how to study that network of models. And I think Hugging Face as a repository is growing to a level that is becoming the go-to place to share models. And there you might be able, instead of on the literature traces of models, you can see that on the models themselves, and even on code, or on this documentation that we're starting to have in nowadays of what the models are based on. So you can see, yeah, if you have a word2vec that then has influenced fast text, that then has influenced, and so on. If the influence is really direct in the model itself, you could identify that and perhaps see if a model is biased for gender, does it propagate down to other models? downstream. So it's very exciting topic. I think you have very, very different sources to do that.
Oh, thanks for the suggestion. That's, the Hugging Face, just being relatively new to this domain, it's just sort of astounding. I mean, it's feeling you sort of pull in one of these large language models into your system, even just locally on your own machine, and then you just sort of have a field day with it. It is amazing to see that growing community. So that's an interesting point. I'll have to go take a look at the end.
Maybe it's too soon. Maybe it still needs to grow more so that you can have actually a sufficiently dense or large enough network. But the idea, I think, could be applied. I hope you can. Yeah.
Well, thank you. Yeah, that's a great idea.
Oh, and a second comment regarding Luke, the name. So if we didn't say Luke, it's because linguistic inquiry and word count, the text analysis method, is pronounced Luke. And that's probably the father of the Star Wars pun in sentiment analysis, with Vader being the dark version of Luke. And I want to say Leia, that is the cool version of Vader and Luke in the family. So you might have a bit of misapprehension if you call it Luke in your case.
Yeah, good point. I meant to mention that actually, because I've used Luke, the original Luke, but I like our Luke because it'll. But anyway, that was just a joke, of course. But we'll have to come up with something. but thanks. Yeah,
I think it's good enough. Yeah, maybe I feel awkward when I pronounce it Luke or something like that. So it's all right. I will be happy to pronounce Rick Tails Luke rather than Pennebaker's Luke. Yeah.
Thank you both. Now, so for the end, there is something that's occupying me whenever we talk about these advanced ways to extract knowledge about human sociality from these large corpora. And those are some ethical concerns. And Rick, you mentioned some ethical concerns. And I want to talk about two things, and also looking at Sushang being here, as the representative of someone who could think of what infrastructure is needed so that we avoid maybe some problems that we faced, decades ago when we were doing research on psychology students. It also touches on Rob's comment. Anyhow, first thing, one is, the samples of language that we currently have are mostly coming from English-speaking or Western, weird populations. Obviously, if it would be possible to do it on other language systems, how difficult would that be? Is that something that requires that would profit from having an infrastructure, maybe funded by NSF, or where there are basically friend labs in other countries that are applying the methods that you're developing, or vice versa, on other samples, so that we avoid the mistake of, oh, we found something on these data sets, and it's so tempting to conclude something about human psychology universally, but is it useful to set in place that kind of more international infrastructure so that immediately we have data from many different languages, so it's somehow facilitated? Because of course, you two are alone, you have your labs, but you cannot do it all. But what would it take? Can you talk a little bit about it?
Sorry, so that was
something useful,
It's for everyone, or for Rick first,
but for
right?
the two of you.
Aha, for the two. Rick, do you want to go first?
Well, I was going to put Gulsha on the spot, actually, and I don't know if she's comfortable with that. So Gulsha is a PhD student in our program and can probably comment on this specifically, because I think you just submitted a paper, a multi-language paper that explores a particular computational model, and you collaborated with several students, all of whom speak different languages.
Yeah,
and so
that's
you were
true.
working on it. Go ahead. Yeah, sorry.
Hello, good morning, everyone. The thing with it was, like, I'm not like an expert of text analysis at all, actually, but I'm just.
I think we lost
you.
Oh, sorry, we lost you. Maybe Rick, can you how do you call it, recover?
Yeah, I'll
what she would say.
Yeah, I would say, so I guess my immediate thought, I'll be brief and I'll give David the floor. I think, working with journals a lot and so on. So for example, the National Academy of Sciences in the US has an interesting workshop every so often about how to internationalize US journals, for example. And there's just a gigantic linguistic bias in almost all respects. And it even is rooted fundamentally in, the language used to publish science as well is all English, So I think there's my answer would be fundamental need to incentivize this, because there's such a strong incentive to publish with English because of the likely reviewers and journal outlets and so on, that I think it may be possible to use a resource that David mentioned, Hugging Face. It may be possible to work with both public and private in order to incentivize building of these models to get them instantiated and actually usable by others. But that would be how I would answer that. David, I don't know how you.
Yeah, myself, especially Hugging Face in this topic, it feels to me like the most groundbreaking advance in AI. Just making things easy to use for everyone is what might actually be advancing more than just increasing the target by 0.001 F1 and so on. So I do think that opening it for everyone is important. Of course, there's some ways to do it better than others. We have quite a fetish for having the best performance possible, and that requires a lot of computational resources. And sometimes we don't need it to be so good, and we can use a smaller model rather than the bigger one, or distill what is called make a big model into a smaller one so that it's more efficiently usable. And I think it's important to lower the barrier for scientists in other countries to start working with these models. When you sacrifice a bit of the awesomeness of the machine you are presenting by making it more usable for others, especially in their languages. That's, I think, one important entry point. And the second is, of course, developing multilingual models. Ourselves, we have some funny stories, actually. So once, for example, we ran accidentally an English model trained with the English Semeval, but in Spanish tweets, in the Spanish subset of Semeval, and it performed pretty well. And so it wasn't a multilingual model that, we look at the head for another language and so on. This was a mistake, and it still performed pretty well. And we suppose that is because it learned from code switching in tweets in which people are using Spanish and English, or code mixing. And from that kind of garbled context, it managed to create quite a good measurement of very frequent emotional words in Spanish that happen to appear also in English. So I think there's many ways to do these things in a dirty way first, and then to do it better, so to speak. But motivating people to play around with a lower barrier, so to speak, I think is the best way to get people in the bandwagon and not just have the typical white English approach to language.
Also, you're back. Would you like to say something?
Oh, hey. Yes, everyone, I'm back. Can you hear me now?
Yes.
Oh, okay. I don't know, I kept talking and I don't know which part you were able to understand, but yeah, I'll start over again.
You're
Okay,
not an
okay.
expert. That's what we heard.
Yeah, I'm not an expert. That's true. So yeah, what we did was just collecting news on COVID from different countries, our own countries, including Turkey, Korea, China, and many others that we can have the skill set to analyze. And then we applied, I think the idea was to see if this method, it's called ANTMN, it's a multi-stage text analysis method. It combines LDA, latent, brilliant, allocation, whatever, I don't know the exact name, but some network science methods like semantic, applying LDA, and then it creates a semantic network to analyze the topic clusters, which then can be seen as news frames. And we wanted to compare if this specific method works with different languages, because it's trained with it's generated for English, it has been applied only to English and not many other languages. So yeah, that's what we did, and I would be happy to share the preprint we just submitted.
Okay, thank you. Yeah. No, that's great. I mean, I had another question, but maybe I think we are coming back to the hour. It's just in my mind, there are these synergy grants, right? Wouldn't it be nice if there's kind of a network of labs in different countries, and when David or Rick come up with a new technique, they it's not like you don't need to wait for them to find it on repository or in Hugging Face. They it's the new technique is automatically shared, and they are, they have resources to also implement it on their data set. That's my vision. Anyhow,
and that's why Susan wants us to apply for an Excel net somehow.
Excel net, that was right. Yeah. That seems like an ideal case, right, Susan, for that?
Right. I think, to really make, to have these models be trained on a great variety of different types of data. So even without talking about countries internationally, if you're looking to leverage the technologies affordance of having a more diverse population and larger scale population you can reach, there's a great diversity of sort of dialectic language use within different groups in the United States, and people coming in but still speaking English, but with a bilingual background that sort of, so even within the United States, it'd be important to have these models be trained on attention on different types of data that exist for different populations within the United States. Even before we need to go internationally, of course, that was also an important aspect. So what do you think? So what would be needed?
So if I might just jump in, I think the most necessary data is a corpus. So to have enough text, especially or transcripts of verbal communication, if you're looking at dialects of a language. So Wikipedia is usually a good resource for that. And when we've seen models for niche dialects, sometimes Wikipedia has dialects. It's the go-to place for people when they're looking for this. But if there's something else that doesn't have a Wikipedia version, the most important thing will be to produce good quality data that the models can learn from. And I think that is where the bottleneck is for these big initiatives. Which kind of data can you get that is large enough to fine-tune a model? How large is large enough is a lot. It need to be Wikipedia level edition. Yeah.
Well, so it's a pooling of resources, because I can tell you that from our program that we have funded people who are building these corpus of like dialectic information from different groups. And how do we get people connected to right individuals connected to each other? I mean, I think that's the problem. And my encouragement of this group to not, to share the kinds of resources and methodologies. I often hear people say, I could have used that method. That was very interesting. It could be applied to my study. But I don't know whether that's ever going to happen beyond the workshop, and so I think having kind of a building of connections among members of this community will be important benefit for everyone.
My impression is that all of these researchers put their code and everything online usually, so all of that is available. From my perspective as a relative newcomer, it is there are two things. One is like, if, for example, if I want to do if I want to apply these models on Croatian, where I'm from. So one is to find a good enough corpus, as David has said, but also then is to find a person, a student who can understand both who speaks Croatian, but also, so he needs to be they need to be well versed in the language, but they also need to be proficient enough to understand what David and Rick, they're super intelligent models, which, to them seem like it's easy, everybody can do it, but it is a learning curve to learn that and apply it. So, I guess it's probably a series of interactions between labs or workshops or people present there, and I'm sure that everybody's open to that. It's just maybe it needs a little bit of infrastructure to to make it easy, because nobody really has time to start anything on their own. Somehow the infrastructure needs to be there, so it's kind of obvious. We have this lab in Korea or in Croatia. There are these couple of students that are really interesting. We'll have, a small workshop with them. We'll explain the method. They will apply it on the data, but somehow it's already there, so you don't have to. Rick doesn't have to call me and say, "Hey, Mirta, do you know someone in Croatia?" And I don't need to, so somehow it's in place. It exists. There are, points of contact, let's say, for those things. That's maybe naively what I think. Okay. Any other comments? If so, then I think we need to break for today. And then the next time, thank you so much, David and Rick. That was so inspiring. And the next time is our last time, right, Marina? It's just we have one talk and then we have an open discussion.